Good morning, students. So in our last class, we complete the question number 3, is not it, from the exercise 6.2. So now here, today we discuss the next question, question number 4. And if you see the question is given here like in this way, in figure 6.19, figure is given here, DE parallel to AC and DF is parallel to A. Two conditions are given. First one is given, D is parallel to AC and DF is parallel to A. And we need to prove here BF by FE equal to PE by EC we need to prove. So now here, if you see the diagram properly, here in this diagram, easily we can identify two triangles. So now before this, let's start here. If you see the diagram first, if you see the diagram here, the diagram is given like in this way. The diagram is given, this one is A, B, and here it is C. This one is given the diagram ABC, isn't it? And now here two lines are drawn. First one is AE. So if you see here, first one is here. If we see AE, and another one is here drawn, and which one is mentioned as DF, and this one is here drawn DF. These two are drawn here, or these two are given here. So two lines are given. First one is AE and another one is AF. So in this case, now these two are again here we have to join which to DE. Now here we have to join, this one is DE. This one we have to join. So now in this case what we get here, first of all, already I told two triangles are here. If you see the first triangle, if you see A, B, C, this one is a triangle here, another one is here D, B, E, this one is another triangle. So now here how can we find out the result here? Result, what we need, the result we need here BF by FE. So here we need the proof BF by FE is equal with, the next one is here BE by EC. So this one we need BE by EC. This one we need to prove. The proof is this one. So BF by FE equal to BE by EC we need to prove, isn't it? So now here what you have to do, first of all, if you see the triangle BABC, and here already mentioned what, DE is parallel to AC according to our question given. And if we consider the second triangle ABE, and in this case already mentioned DF is parallel to AE, this one is given to us. These two conditions are given. So the first one is given, DE is parallel to AC. You see DE is parallel to AC, and the second one is given here DF parallel to AE. These two conditions are given. So now here, that's why here separately drawn is, it is more visible to check out here the parallel lines, isn't it? So DE parallel to AC as well as DF parallel to AE. Clear? So now here how can we prove this one? Let's see here. First of all, if we consider the triangle ABC, so if you write in triangle ABC, in triangle ABC, and already given here, what given? If you see the triangle, this one ABC, DE parallel to AC. So that means here already given, this one is DE is parallel to AC. In bracket you have to write this one is given. Clear? So now if we draw the diagram separately here, if you see, so this one is the diagram here. So here A, this one is B and C, and already mentioned D is parallel to AC, so D, E. So that means this one is D and here it is E. If we separate the diagram from here, so D is parallel to AC. So this D is parallel to AC. If this D is parallel to AC, so easily we can apply the Thales theorem here, isn't it? For this one is the third side here, and the opposite vertices is B here, isn't it? So easily we can apply here the Thales theorem. Or if we apply the Thales theorem here, then what you have to write? BD by DA, because these two are parallel. So that's why here we have to write BD by DA is equal with BE by EC according to our Thales theorem. So that's why here we have to write this one is BD by DA is equal with, we have to write BE by EC. So that's why here we have to write BE by EC. So we put this one is equation number 1. All of you understood this one? So just we have to separate the diagram from this combined diagram. So now here next one is, again if you see the another triangle here we have to consider now ABE. So this triangle we have to consider. So that's why here we write in triangle ABE. So in triangle ABE already given here DF. So this one is given. Now second time DF is parallel to this one is given AE. So here given. So if you see the diagram separately here, so this one is A, here it is A, this one is B, and this one is E, and here easily consider this one is D at this point, and at this point it is F, and here already mentioned DF is parallel to AE. So if DF is parallel to AE, so easily we can write here, easily we can apply the Thales theorem, and the Thales theorem is what? BD by DA, because third side is this one, so opposite vertices is this one. So that's why here we have to write BD by DA. So in this case again we have to write BD by DA. So BD by DA is equal with BF by FE, easily we can write. So this one is we write here BF by FE by Thales theorem. All of you understood this one, isn't it? So BD by DA is equal with BF by FE. So if you see here, at first two diagrams are here combinedly given, and if we separately draw, then easily we can apply here the Thales theorem. So this one we write equation number 1, as well as this one we write here equation number 2. Is it clear? So now here if you see the equation number 1 and equation number 2, BD by DA is here, as well as in the second case you see BD by DA is here. So if the left hand sides are equal, that means right hand sides are also equal. So easily we can compare these two results. All of you understood? So if we compare equation 1 and equation 2, so that's why here we have to write from 1 and 2. So if we write from 1 and 2, if the left hand sides are equal, that means the right hand sides are also equal. So that means what you have to write here? This one you have to write BE by EC is equal with, here this one we have to write BF by FE. So this one we have to write BF by FE. So let's check out the proof here. So this one is our proof, BF by FE, isn't it? And next BE by EC. So BE by EC. We get this one. So this one is our proof here. So if we repeat the question one more time, first of all, here two conditions are given. At first two conditions are given, and these two conditions are given what? First one is DE is parallel to AC given. Only for that reason, when we have to take the triangle ABC, that means the whole triangle we take, and in the first case we take DE is parallel to AC. That means we take only these two, DE and AC we have to take. So if you see the diagram is this one. So if D is parallel to AC, so easily we can apply the Thales theorem. And Thales theorem is what? BD by the ratio of the corresponding sides. So that means BD by DA, BD by DA, BE by EC. Understood? We put equation number 1. Similarly, the second condition is given here, DF parallel to A. So that's why in this case we have to take the triangle ABE. So if we take this triangle ABE, so you see here ABE, this one we take. And in this case, this DF is parallel to AE, isn't it? So if DF is parallel to AE, then easily we can apply the Thales theorem one more time. So here BD by DA equal to BF by FE. So this one we write here. So if you see equation 1 and equation 2, the left hand sides are equal, so that's why we have to compare the right hand side. So that's why finally we get here BE by EC equal to BF by FE, or this one. If we rearrange this one, and then here we write this one is BF by FE is equal to this one we write BE by EC. I think all of you understood this one. So this one is our proof. So today here we complete the question number 4. So in our next class we have to continue this exercise. I hope all of you understood this one. So you have to copy this question properly, and in our next class we solve question number 5. Okay, thank you.